Hey guys, welcome to Houdini Day here at FMX. My name is Chris Hebert. I'm the head of marketing at SideFX. This is by far my favorite thing all year to do. So I'm really excited and happy that we're all here together to see and participate in this Houdini Day. The day is a mixture of SideFX people like Kai here, some studio people. There'll be some things that are more educational, some things that are more inspirational, and hopefully it's a nice mixture that there'll be something for everyone. The schedule just outside the door, I used a marker to kind of fix it, but it was wrong for a while. Online, on the website, on the app, it's correct. So Kai's first Helge Mouse was originally scheduled for 10, was moved to 5. So if you're looking at the schedule online, it's all good. Just a quick tee up on Houdini. There's lots of information on sidefx.com. So if you see stuff today and you want to learn more about Houdini, sidefx.com. There's tutorials, galleries, forums, all that kind of thing. So definitely that's your first go-to. Our Facebook page is where we update on a daily basis all kinds of whatever we find that's interesting, stories, Houdini Connect customer stories, tutorials that are out there that we want to feature. So our Facebook page is continually updated every single day. Webinars we're doing on a fairly regular basis. About once a month you'll see live webinars, sometimes SideFX people, sometimes people from the industry. And if you ever want to use Houdini and you don't have it yet, there's an apprentice version which is free. You go to sidefx.com/get or buy or something, but it's apprentice is free. So it has the same power as Houdini effects with some minor limitations, like it's got the watermark on it, and it can't render out at certain resolutions, and you can't use it in engines. But otherwise, it's the same capabilities as the big studios use, and it's free. After Kai speaks, actually probably after at 11 o'clock, after the second session, at 11 o'clock, we'll be giving away some T-shirts. So come on up and get yours after the second session, and after each session. So over to Kai. Kai Stavginski is is a senior TD at SideFX working on fur and grooming tools. He spent 4 years in London as a TD, working in studios, and has been at SideFX for 3 years. Lots of experience, and can't wait to see what he has to say about fur and hair. Over to you.
All right, thank you, Chris, and good morning, everybody. So I want to give you a broad overview of the new hair tools in Houdini 16. Some of you may know that we have a completely new set of tools there. We've had fur in Houdini for a long time, and it was working pretty well. People use it in production, but over the years, we've just got requests for things that are maybe hard to implement in the old system, and eventually we decided we're just going to go completely new. I'll also mention some of the broader changes in Houdini 16 that we benefit from with the fur tools. For example, here you see our new desktop for grooming. So we have the drop-down menu at the top there where you can select desktop, which just completely changes your UI and specializes it to a certain task to some extent, which is really nice for grooming because you have all the brush and procedural tools that you might need right at your fingertips. And then the radial menu that you see in the viewport there allows you to quickly jump back and forth between all the objects that make up a groom. So that's something that is really useful for modeling and many other interactive tasks. And it's perfect for this grooming stuff. So the tools really benefit from that. And then talking about the grooming tools specifically, so we used to have this monolithic single object where you managed all your grooms. So that contained the guide curves, so that's like a sparse set of curves that you actually set up your groom with, and then the full hair, where you generate hundreds of thousands of strands of hair, that was contained in the same object, and it just led to, well, it's a nice self-contained thing, which makes it easy to manage in theory, but we realized it actually doesn't work that well when you go to complex grooms and you use it in full production, which is where we where we are, right? We want to do very high quality characters down to simpler cartoony characters. We basically want to support all of it. But to make it easy to work with complex things, we found it's better to go to this modular approach where we have completely separate objects. And each of them is much easier. Like the parameter interface on them is much, much simpler now, you'll find. And they each have a single purpose. And the other thing we did with this redesign is inside these objects. So the guide groom here, that's the object where you set up your curves and you do your combing and procedural manipulation and all that. It's a context that contains everything you need for a groom. So you have the guide curves, the skin geometry, it's all in one place. And the purpose of that is to make a final groom, you need to manipulate all these things at once. You need to comb the curves sometimes, and sometimes you just want to paint like an attribute on the skin. And having it all in one place makes it much, much easier to do that. And then what you also see here is these new types of operators, these grooming operators, like the guide process there. They have these 3 inputs where everything flows through, and it just leads to a very clean network. You'll see that a bit later. And another thing with this is these same operators can be used to manipulate the fully generated hair. So you can use the same, you learn one set of tools, and you use it to manipulate the guide curves, where you might just have like 5,000 or something. And the same tools apply to the full hair, which makes it really, really powerful and flexible and just easier to learn as well. You'll see more of that later. And here I'm just showing how you might work with these operators. So we start off with a guide process that just sets a direction, and it uses an attribute that you can paint on the skin. So here I'm just using a comb node, which we've had for a long time, but it's sort of got a new lease of life with this because it's very useful within this new context. So you just paint a normal direction on the skin, and then you have a separate operator to set to use that direction as your direction for the guide curves. And that workflow is really, it's a simple thing, but it's very powerful because you don't manipulate the guides directly. So we don't, the end result is not like a geometry of the guide curves that we store. We store, like with everything in Houdini, we store the process that produces that result, right? So if you make underlying changes, like maybe you've already, like your eyebrows are perfect, you have them exactly like you want, but then you find, maybe I need a little bit more detail, I need double the guide curves or something. You can just change that at the top and everything trickles down and recomputes and just works. So it's very easy to make those changes very late in the process. And then here's just another example of how you might use it. So the guide process, we have this lift operation here where you can basically say how much the hairs lift off the skin. And we paint that in here as a mask. And this just illustrates, we have a really nice mix of this procedural approach where you work with nodes, but you can also just, you don't really have to think about that too much. Like you just create your guide process node, and then when you find you need to, like rather than setting a parameter globally, like the lift, so everything changes across the whole character, if you find you need to paint that in some areas, so some areas of the character lift more than others, it's very easy to add that and paint all those masks. And again, everything stays procedural, so when something changes upstream, even your character model, everything updates. And then here we're jumping over to the hair generation side. So now I'm not working with those sparse curves anymore, I'm working with the full hair. And it's exactly the same nodes. So you still see a guide process node there. And I'm just setting random lengths on the hairs. And these now affect the actual individual hairs, right? So you can have a randomness to that. And then we have this very powerful clumping operator where one new thing there is you can do it on the guides. So you can take those sparse guides and clump those. And then when you generate hair from those guides, the generated hair will be clumped as well. So that's what you kind of see there. And it's going to be taken into account in the simulation. So when you then simulate a clumped hairstyle like that, when you have a collision object interacting with the hair, the clumps will react properly, and that was very difficult to do. But then you can use that same clumping operator in the hair generate part here and just add another finer level of clumping. So that's something you often want to make it look really realistic. Right? You do a high-level clump with like large clumps like you see here, and then you break that up a bit more. So you have smaller clumps within that, and that's how you get more realistic, natural looks. And it's just a lot easier with these controls. So we call that fractal clumping, and it's built right into that operator. So you can do as many iterations of fractal clumping with subsequently smaller clumps as you want. And this is just like a cartoony, simple example of that. The nice thing is, compared to before, like you actually had to spend a lot of time just getting anything, like just getting something that looked nice at all. And with these tools now, we find that you get something that looks pretty good right away, and you spend more of your precious time just getting the specific look that you want, rather than just something that looks like anything. So you get nice, realistic clumping, and then you spend your time, really tweaking specific areas. Like you have a furry animal or something like that. Like you're creating the fur on your wolf model or something, and you just spend the time painting the different style of fur that it has on the belly versus the ears and that kind of thing, and it becomes a lot more just artistic. Oh. Jumping over a slide here. So this is an example of the simulation improvements we have. So this curly here uses the same clumping system, actually. We simulated this without inter-hair collisions, by the way. You see some penetrations, but you can simulate it both ways. Sometimes one or the other is better depending on the distance you see the character at. But this should be looping. You see how the curls stick together in the simulation, right? Which is that's not a surprise. Like that's what you expect. That's what should happen. The point is that it does that now. You don't really have to think too much about it. You set up the curls in the guide curves. So you just for each curled hair, you might have like 3 or 4 guide curves, and then the generated hair from that follows that really nicely without any effort. And the guides, when you simulate those, they stick together, and you keep that clumping and curled look through the simulation. And then here's just another example. So it's a bit more subtle, but you can see that in the beard as well. The clumps stick together a little bit. And then the hair was supposed to have that gel that stuck together look a little bit, and you can use the same system for that. So the way those clumps work in the simulation is we just have another set of curves that connect between the guides, and those have their own strength and spring properties. So yeah, it's very easy to set up, and you get nice natural look out of that pretty quickly. And here's just another example of rendered hair. And I just want to mention again, the way we render hair now is we use those operators that I was talked about before. So at render time, we'll generate that the dense hair from those guide curves. So they're driven by the guide curves. But then you can make those additional manipulations, like the finer level hair clumping and frizz, and add all those things. And it's using those SOPs. And the neat thing there is you can also use any other SOP. Like you can use all of the power of Houdini in there, and it's generated at render time. And you don't even have to write it to disk, right? But you get all of the power of Houdini. So you're not, before you were constrained to this other system where we used CVEX and it was quite technical and difficult to do complicated things. And now it's quite straightforward. So if you know Houdini and you know like just general operators that work on curves, like the carve, SOP, or resample, you can use all of those at any point. So it makes it easier to do things like, well, you could work with fairly low resolution hair initially, all the way through the process, like maybe just like 4 curve segments per hair. And then if at render time you want to add like very high frequency frizz or something like that, you need more detail, you can just add that detail with a resample SOP at any point and do it there. So there are a lot of efficiencies and new workflows to be gained there. All right. That's it. Questions? Was I really fast? I was really fast. 15 minutes of questions in our 30-minute session. Has anybody used the fur tools? Houdini 16, a little bit. Yeah. So I mean, if you have more questions later, come and ask. I didn't mention I'm the guy who developed 90% of the stuff. So if you have questions, I'm the right person to ask. I'm here.
Hi, maybe more of a comment rather than a question, since we have time. Or formulated as a question. I think this is like, for me as a non-programming like artist type, and this is exactly what I'm hoping to see more of in Houdini, where there's less node diving, there's less like trying to figure out where I am and where things are coming from. Is this? I kind of see this as the new direction.
Right.
Of keeping the power for the TDs, but giving people like me access, and it's like a desktop where everything is there, and I'm like fascinated. I'm very happy.
Right.
So that was my comment. I'm hoping that it goes. The development continues to go in this direction. Really nice.
Yeah, it's a clear goal for us. I think that's safe to say.
It feels very consistent also with like the terrain tools and fantastic.
Yeah, it is. It's something we want to do with everything going forward, I think, and it is a difficult balance, because we do have a lot of like very long time hardcore users that are used to just diving into everything and breaking it apart and making whatever they need. Like, I've just had someone tell me, well, we don't really care about the tools you add. Like, we really care about the underlying architectural improvements, right? Because you can build, in theory, like if you have the technical knowledge, you can build anything you want in Houdini. You don't need the high-level tools. But of course, that's a small group, and we need to strike that balance between.
But they still have access to those things with the new implementations, right?
Yeah, exactly. So we build everything. Like, a lot of Houdini is actually built with HDAs, with digital assets. So a lot of these tools are actually not built in C++, because we already have the underlying functionality to build this stuff within Houdini, right? So the way I build tools like this, uses the same. I use the same stuff that you have access to in Houdini, right? And that's how we end up with these multiple levels of things. So you can use these things as they are. They are great for tools. They work very nicely. But you're never going to be in a, like, if you find yourself in a spot where you don't have exactly the right tool for some specific tweak, there's nothing stopping you from jumping over to some completely unrelated tools and just go in and code a little bit. And it's not a huge jump to that, right? You can use it for little parts, and you still get the broad, like, flexible, simple tools for the more general tasks. Yeah. Anyone else? I guess we could do T-shirts now. All right.
Is Darryl Atkins here? Darryl Atkins? No. So he's our next speaker. Hopefully he'll show up quite soon. Yeah, if you guys want to do a quick round on the T-shirts, we can do that now. That'll save time later. Yeah. Yeah, of course.
Yeah. Thank God.
Hi. So first of all, I really loved it. So great job. I'm assuming that there's a connectivity to all the other DOPs and simulation possibilities, but could you expand a little on like that area? Like, if we want to combine the new hair tools with like liquid simulations or stuff like that.
Yeah, so just due to the way Houdini works, we didn't have to do all that much specific work for that. It really works quite naturally out of the box. It is a difficult problem, like, depending on what you want to do. Like, if you want to simulate like a close-up character with hair interacting with fluids, like, it takes work, but the basics will work. So, like, having a flip simulation influence hair.
Yeah.
It's pretty straightforward. But there's even more work we want to do, like wet maps and like changing the shading when the fur is wet and those things. It's not quite there out of the box. It's like, if you know Houdini, it's simple enough to do, but there will be more like one-button solutions for that in the future.
Okay, cool.
Yeah.
Thank you.
And how it is with curls, because curls do behave completely differently
Right.
when they're wet, because
Yeah.
they're going to be straight.
Yeah. So again, it's not built in, but it's very easy to change properties in the sim based on some external condition. So you can basically detect and store when hair has been in contact with liquid, and then you can change any property on it. And the simulation then from that point will take that into account. So you would do something like, well, we have this bend resistance in the hair. That's what makes sure that the hair stays in a specific like configuration, like the curls, right? And if you lower that a little bit, then the hair is allowed to bend a bit more. That's what you'd probably do. And then same thing would work in the shader, right? So for shading, you would make it a bit more shiny, like more reflective when it's been in contact with water. So you can use the same system for both those things, pretty much.
Thank you.
Thanks for the question.
Any other questions?
Hi. Ooh, very
Hello.
loud. This isn't specifically about hair, but it's you mentioned something about you write your own tools using the existing tools, and you don't necessarily have to go into the C++ API.
Right.
Is there a reason? When are you forced to use the API? Is it purely due to speed, or do you prototype using the existing tools and then go into the API, or
Right.
could you talk a bit more about that?
Well, for ourselves, for our own development on Houdini, we try to make the C++ work like we only go to C++ when it's supposed to be very generic. Like there used to be a time where you would write every operator in C++, and nowadays we only do that for very, very low-level things like renaming attributes, that kind of thing, creating a group, deleting a group, those things. But these higher-level tools, like a fur tool, you would not go into C++. And the great thing is the performance isn't even necessarily better in C++ because we have Vex, our own language, which is quite technical to go in there and write code, but you're so much more productive than when you go to the low-level C++ stuff. And when you build those things with Vex and just Houdini operators, it's usually just as fast. Like 2 versions ago, when we added the grain solver for like sand simulation, snow and things, we initially wrote that in C++ and in Vex, and we threw out the C++ implementation before release because it was slower.
I'm glad you did. Hello? Yeah. I'm glad you did, because I dove into the grain solver and it helped me learn some things. So thanks.
Yeah.
Anybody else? Yeah.
Hi, thank you first for all the work. It's an incredible tool. I just wanted to ask if you can talk a bit more about the licensing process and how the render works. So when the license is pulled, and when I well informed, then you don't pull a license on curve and point rendering, right?
That's right.
So we could eventually do something like in Krakatoa to generate points at render time.
Unfortunately, no.
Okay.
That you would need there are 2 options there. You would need an engine plugin in there, but it would pull a license. Or you write all the hair to disk. So, yeah, that's the reality. So the free hair generation is only in Mantra. But yeah, you can do it. And one thing that does make it possible to go that way is we have fairly new mechanism where you can pull the engine license while it's generating the hair or whatever it's generating, and then return it before the whole process finishes. So if you do have a plugin for your renderer, it would only take the license while it's generating the hair and then finish the render. If the render takes 4 hours, that's fine, right? It doesn't keep the license. So you might not need that many licenses there, which makes it realistic to go that way, I think.
Thanks.
Hair generation will take like a minute or 2, right? At most.
Thanks, Kai.